Hi kids, we are going to do another MGears enrichment, and as always it's a good idea to get out the parts you'll need before you actually begin building. So let me tell you what you'll need. You will need one yellow peg, okay? You will need 11 blue pillars. You'll need a total of 10 six-way axles, 10 of those, and you will need 2 red gears and 2 yellow gears, okay? So again, I'm going to go over those with you. You will need 1 yellow peg, you will need 11 of the blue pillars, you will need 10 of the six-way axles, and you will need 2 red gears and 2 yellow gears. So why don't you pause the video and put your parts together, lay them out the way I have mine, okay? Because I want to go over a few things. All right, hopefully your parts are spread out or organized the way I organized mine, okay? And, let's just talk about ratios and how they would influence design and how you think about a design, okay? So, we have a ratio of gears to axles. And basically we know that gears imply there's moving parts and axles imply there's moving parts. But how many moving parts are we going to have? Well, if you look at this, our ratio of gears to axles is 4 to 10. Okay? We have, for every 4 gears, this project needs 10 axles. Okay? So the ratio is 4 to 10. Now 4 to 10 can be simplified down, and we can divide both 4 and 10 by the number 2, okay, the greatest common factor of 2. So if we divide our gears by 2, we get 2 groups of 2, and if we divide our six-way axles by 2, in other words, we put them into groups of 2, we will end up with 5 groups, okay? So we have 5 groups of 2 and 2 groups of 2. So it would be a 2 to 1, 2, 3, 4, 5 ratio, okay? 2 to 5, all right? And so we could break that up and say that for every 2 axles, you need 5 gears. So that's just kind of a neat way of looking at ratios and the way you can combine those thoughts. The other thing I want to point out is we have these 2 gears. Okay, we have a total of 4 gears. We have 2 colors, and if we set them up like an array, in other words, we have a length and a width, or we have a row and a column, we could say that this is 2 by 2. It's a 2 by 2 array. In other words, it equals 4 things. So in other words, 2 times 2 equals 1, 2, 3, 4. Okay, now the axles, if we try to make an array out of those, we might look at it and think, geez, I can't make a square, okay, because I have 10. However, you could actually make an array. You could make yourself a 5 by 2 array. In other words, 2 times 1, 2, 3, 4, 5 gives you 10. Okay, so that's just kind of a neat way of looking at the parts you have. All right, so now let's get started building. Okay, the first thing we're going to build is this. Okay, this is the first thing that we want to build. Now it's really important, whoops, there goes my camera. It's really important that we position the axles correctly, okay, when we're doing this project, all right? Now, here's what you're going to do. First thing you want to do is you want to take one axle and you want the split to go up for this process. And then there's the peg that comes out. You're going to stick that, whoops, you're going to stick that, that was a good catch actually, on like this, okay? So you have it on there like this. The split is going up for this position, okay? For this view. Then what you're going to do is take a blue pillar and you're going to put it on the opposite side of the peg, okay? So we're still orienting this split so that it's up, okay? Then what you're going to do is take another pillar or another six-way axle, and when you put this on, you're going to want the split going up also. So you're going to slide it like that. Okay, so the split is on the top. Okay, there we go. Split up the peg this way. Okay, now the next thing that you're going to do is you're going to take another blue pillar and you're going to slide it in like that. Okay, so you can see that we've got the split cylinder peg, blue pillar. Then you're going to put a blue pillar off to the side. Okay, so now this is what we have. Okay, and you notice that you have intersecting line segments along here. You have a line of symmetry right down this way. Okay, and so that's kind of neat. If we look at it this way, we can see lines of symmetry up and down. Okay, anyways, now we're going to finish this off by taking another 6-way axle, and this time you want the splits going on the same plane as the peg split. Okay, so you have the split cylinder here, split cylinder here, split cylinder there. Okay, that's important. Then on the opposite side, you're going to put another one, same way, and you want the splits to go forward and back, okay, from this orientation. So you have split cylinder, split cylinder, split cylinder, split cylinder, split cylinder. Okay, now this part is actually done, and how it actually sits is like this. Okay, that's actually how it sits. Okay, and so you have, see if you can get yours to balance on that point right down there. Okay, now when you look at this, you'll notice that it has a line of symmetry that goes straight down here. Okay, so if you're looking at it from the front, you can see that you have a line of symmetry straight down. If you look at it if you turn it from the front and you rotate it and you look at it from the side, you have a line of symmetry very carefully drawn through here, and it's symmetrical that way. That allows this to balance. Okay, so this is the front right here. I'll face it towards you. Woo, come on. It doesn't want to stay up. Oh, you know what? Maybe if I spin it, it'll stay up. Maybe if I spin it, no, not doing it. Okay, so anyways, let's go on to the next couple parts. All right, the next parts you're going to make is you're going to make 2 of these. Okay, you're going to make 2 of these parts. All right, now let's take one of these axles, okay, and you're going to slide it in like so. Okay, and we're going to pretend that the split is the top part. Then you're going to take another axle and making sure that the split cylinder is going up. Okay, split cylinders are going upwards. Okay, and then you're going to put another pillar on there and a third. Okay, so now you have this, what looks like a beam, and you have split cylinder going up, split cylinder going up, split cylinder going up. And you're going to make another one of those. So we'll get a 6-way axle, split cylinder is up, pillar on the side, pillar on the side. Grab another 6-way axle, split cylinder is going up, and the split cylinder is going up. Okay, so we have 2 of these beams. Okay, those are going to be kind of important for us. Okay, now remember, we were trying to get this to spin, right? Couldn't get it to spin. It's symmetrical, it's balanced. We got it to stand up like, oops, we got it to stand like that at one point. Ooh, there it is. But we want to get it to spin. Let's see if we can do that. So let's take our remaining 4 blue pillars, and we're going to put them here and here. Okay, so if you look, we have a line of symmetry. If you look at it from this angle, we have a line of symmetry straight down. But if we look at it from this way, we no longer have a line of symmetry. if we look at it from this angle, from the top down, we no longer have a line of symmetry. Okay, so we want to keep things as symmetrical as we can on all sides. Okay, so here it is facing you. Here's the front, and you can see that we have some lines of symmetry here. Okay, if we turn it this way, we have a line of symmetry. And if we look at it from above, we have a line of symmetry this way, a line of symmetry that way. If we look at it from the bottom, we have a line of symmetry this way and a line of symmetry this way. Now, can we balance it? Ooh, that seems to balance pretty well. Can we spin it like a top? No, not yet, not quite so well. Well, maybe you can. See if you can get it to spin like a top. Ooh, maybe it's all in how much effort you put in. Ooh, there's a pretty good spin. All right, so it didn't make a very good top when it looked like this. When we added to its size, it spun. It actually, we managed to get the spin. Okay, it took a little practice. Ooh, took a little practice, little talent, which I don't. Ooh, come on. Don't get frustrated. You know what? I did get it spinning. Maybe you'll do better. So let's see what happens if we add to this even more. Okay, so we're going to take this beam, and with the split cylinders up, we're going to put it on like that. Now what we're going to do is take the second beam, split cylinders facing up. We're going to do that. Okay, so now we still have a line of symmetry. If we look at it from the top, we have a line of symmetry this way, a line of symmetry this way. We have a line of symmetry that way and that way. If we look at it from the front, we now see that we have a line of symmetry. Okay, we have lines of symmetry there as well. So this thing has got a lot of symmetry and balance. Let's see how it spins. Ooh, wow. That really spins well. Okay? Why don't you practice spinning it right now too? Okay? Alright, hopefully you started the video again. Now, you want to make sure for this next part that you have all these split cylinders facing up. Because what we're going to do is we're going to practice using this spinner with different setups of gears. And you should notice how things change as you put more weight and more parts onto this top. Okay? So when you spin that, you should see a difference. Play around with different combinations of gears. See how it spins. See if you can get it to spin with some gears, no gears, all gears. And if you want, you can create your own spinner, and we might have a spin-off challenge, okay? So anyways, that's it for the project today. You can kind of play around with that and have a little fun with it. There's a lot of concepts in here because you can talk about circles and circumference and that sort of thing as it's spinning. This actually is kind of neat because it talks about operational and non-operational area, like all amusement park rides, like this amusement park ride, it has an operational and a non-operational area. When it's not turned on, it only takes up a certain amount of area. Like this top, when it's not spinning, it only takes up a certain area. But that can change when you turn and get it moving. It might create more area. That's when it's operating. So it might need more operational area than non-operational area. Okay? So anyways, that's the end of this video. Good luck experimenting and building. And you're going to need this to take that quiz, I think. All right. Have a good day, kids.